In 1992, three teams of scientists at different research facilities noticed an unusual signal from a newly discovered pulsar. This discovery sparked a major research race to understand its nature. Eventually, scientists confirmed it was a massive planet, 12.7 billion years old, likely one of the universe's first planets. Hello and welcome to Z. Please don't forget to subscribe and hit the bell icon. Imagine a planet so ancient it has outlasted its own sun. A planet formed before essential elements like carbon and silicon were abundant. Born almost right after the universe began, many would find such a planet's existence unbelievable and improbable. But does it exist? Surprisingly, it does. This incredible planet is very close to us. It formed before there was even oxygen in the universe and existed before our Milky Way galaxy resembled its current form. How is this possible? What's extraordinary about this planet? How did it change over time? Let's delve into the details. The very first planet in the universe. Music. The journey of its discovery spanned nearly 15 years, evolving from hesitant guesses to confirmed facts. Let's rewind to 1987. 1987, a team of British astronomers observed the globular cluster M4, a group of stars discovered in 1746 by Swiss astronomer Jean-Philippe de Chazot. This cluster is fascinating because about 40,000 of its 100,000 stars are white dwarfs, indicating its great age. Additionally, M4's proximity to Earth made it advantageous for study. Initially, the distance was estimated at 5,600 light years, but was later corrected to 6,160 light years. That year, scientists made another significant find in the cluster, a pulsar, named PSRB 1600-2026. This discovery was monumental because pulsars were rare. It was thought to be part of a binary star system with a companion white dwarf. However, confirming the white dwarf's presence required waiting for half of its assumed orbital period, which took 200 days. 1988 confirmation came. PSRB 1600-2026 was indeed a binary system with a pulsar and a white dwarf. Pulsars are rapidly spinning neutron stars emitting focused beams of radio waves. As they rotate, these beams sweep over Earth, creating a pulsing signal detected by radio telescopes. This is why they are called pulsars, often referred to as the universe's beacons. 1992. Three teams of scientists from various observatories noticed an anomaly in the pulsar's signal, indicating it was being gravitationally influenced by one or more unseen objects. At a major pulsar conference in 1992, Dr. Backer from the University of California, Berkeley, suggested that this anomaly could be a third object in the system. Dr. Stein Sigurdsson proposed that this third object might be a planet, possibly stolen from another star. 1993. The discoveries of the previous year captivated and intrigued the scientific community, leading to 4 studies on the PSRB 1600-2026 anomaly within a year. Scientists theorized about the third object, suggesting it could be anything from a black hole to a Saturn-like planet. Each new theory sparked further debate. Over the next decade, scientists explored numerous theories about the PSRB 1600-2026 anomaly. Finally, on July 10, 2003, the Hubble Space Telescope provided the definitive evidence. Dr. Stein Sigurdsson confirmed his hypothesis about the planet and suggested the unofficial name Methuselah. This ancient planet, the oldest known exoplanet at the time, immediately drew global attention. What does this ancient planet look like? It differs greatly from Earth. It orbits 2 suns in the PSRB 1600-2026 system in the Scorpio constellation. The pulsar, PSRB 1600-2026a, has a surface temperature 6 times that of our Sun, reaching 30,000 Kelvin. Despite being 35% more massive than the Sun, it is only a few kilometers in diameter. This incredible density means a teaspoon of its matter would weigh over 100 million tons on Earth. The pulsar rotates at an astonishing speed, completing about 100 revolutions per second, emitting powerful electromagnetic pulses. In contrast, the system's second star, a white dwarf, is relatively peaceful, with a mass just over 1/3 of the Sun. This white dwarf is the remnant of a sun-like star that has completed its life cycle. Our sun will undergo a similar transformation in billions of years. The planet, PSRB 1620-2026b, formed around the same time as its host star, roughly 12.7 billion years ago, making it one of the oldest known exoplanets. It is similar in size to Jupiter, but 2.6 times more massive and 1.18 times larger. The planet orbits the stellar remnants at a considerable distance of 23 astronomical units, or 3.4 billion kilometers, comparable to Uranus's distance from the Sun. Each orbit takes about 100 years to complete. Let's travel back 12.7 billion years. The universe is young, just a billion years old in its infancy by cosmic standards. The concept of the first planet in the universe stretches the imagination and challenges our understanding of cosmic history. The universe, as we know it, began with the Big Bang approximately 13.8 billion years ago. This event set into motion the expansion and evolution of the cosmos, leading to the formation of stars, galaxies, and eventually, planets. To identify the first planet, we must delve into the early universe, examining the processes that led to planetary formation and considering the theoretical implications of such an ancient world. The birth of the universe. Following the Big Bang, the universe was a hot, dense soup of particles. As it expanded and cooled, these particles began to coalesce, forming protons, neutrons, and electrons. Within a few minutes, nuclear fusion occurred, creating the first light elements: hydrogen, helium, and trace amounts of lithium. It took several 100,000 years for the universe to cool enough for electrons to combine with nuclei, forming neutral atoms. This era is known as recombination, and it led to the decoupling of matter and radiation, allowing light to travel freely and creating the cosmic microwave background, CMB radiation we observe today. The formation of the first stars and galaxies. As the universe continued to expand and cool, regions of slightly higher density began to collapse under their own gravity, forming the first stars and galaxies. These population 3 stars, composed almost entirely of hydrogen and helium, were massive and short-lived. Their formation marked the end of the cosmic dark ages and the beginning of the rayonization epoch, during which the first light from stars rayonized the surrounding hydrogen gas. The death of these early stars through supernova explosions enriched the surrounding medium with heavier elements, or metals, necessary for planet formation. The first galaxies, composed of these early stars and enriched interstellar medium, provided the environments where planets could begin to form. Planet formation in the early universe. Planets form from the protoplanetary disks of gas and dust that surround young stars. These disks arise from the remnants of the molecular clouds that collapse to form stars. Over time, dust grains within the disks stick together, forming planetesimals. Through a process of accretion, these planetesimals grow into protoplanets, eventually becoming full-fledged planets. In the early universe, the first potential planets would have formed around the second generation of stars, or population 2 stars. These stars contained enough heavy elements to form rocky planets. Given the timescales involved, it is plausible that the first planets formed within a few 100 million years after the Big Bang. The hypothetical first planet. Identifying the very first planet in the universe is an inherently speculative endeavor. However, it would likely have been a rocky planet orbiting a population 2 star in a young galaxy. This planet would have formed from the enriched material produced by the first supernovae, containing elements like carbon, oxygen, silicon, and iron. Such a planet would have been subject to intense radiation from its young, active star and the high-energy environment of its early galaxy. The likelihood of this planet surviving to the present day is low, given the violent and dynamic nature of the early universe. However, if it did survive, it would be a valuable relic, providing insights into the conditions and processes of the primordial cosmos. The very first planet in the universe represents a fascinating theoretical construct that bridges cosmology, astrophysics, and planetary science. While we may never be able to identify this planet with certainty, exploring its potential characteristics helps us understand the processes that led to the formation of planets and the evolution of the universe. As we continue to explore the cosmos, each discovery brings us closer to unraveling the mysteries of our cosmic origins and the ancient worlds that may have once existed. Thank you for watching. Thank you.